and welcome to this first hints and tips, just shared experience. Building lighting for your scenery. I've been using these small LEDs, tiny LEDs, and I'll put you a link on the post. £8.80 for 50. Tiny little LEDs, great for lighting in small areas. What you get are these very small LEDs, probably about 1mm square, on the end of some very fine wire. And what I do, I get some card, cut it out, and a little slot in the end, and then I'll stick the LED to the card with a bit of paper. Quite a simple little job. Get varying lengths of card, and you get your LED, lay it with the wires on the back. I don't know if you've got to pick that up, but the wires are soldered to the back of the LED, and if you look at the front of the LED, it's just a yellow square, and you just place that so it sits somewhere in that little slot. A bit of neat PVA, and then a bit of paper over it. And then squeeze it down, and it looks like that. And once the PVA is dry and being neat, it won't take long. You just snip off that bit there so it's flush, and then you glue those to the ceiling inside the room you want to illuminate. Now these LEDs, they work at 3.2 volts nominal, and they draw about 20 milliamps maximum. What I do, I put 4 in series, and they connect together, and they come out of the base of the model and go through the baseboard. I solder all the joints and connect it to the 12 volt bus of the accessories. I've got several lines on the layout downstairs, which one is for lampposts, one is for building lighting, and there was going to be some for others, but as you know, I'm breaking that down and continuing with the new layout up here in the bedroom. You can, if you want, it's more realistic to wire the LEDs singly. To do that, you've got to put a resistor in, and these resistors work at around, as I say, 3.2 volts, and they draw about 20 milliamps maximum. And if you use Ohm's law, you can work out what resistance you want. I don't know if you have to pick that up, but what we have is the LED, and the voltage across the LED is 3.2 volts, and if you've got a 12 volt supply, then you need to get rid of the 8.8 volts, and you do that by sticking it in series with a resistor, and the volt drop across that resistor being 8.8 volts. You know the current, so with the current as 0.02 amps, that's 20 milliamps, and you've got a voltage of 8.8 volts, your resistance would be 440 ohms. So a 470 ohm resistor, which is a standard size resistor, would suffice. Personally, you can blow it if your power supply is over, so you can experiment, stick a larger resistor in, and you could get it dimmer. So you could experiment with the size of the resistor to get a smaller brightness, so it can be more realistic, and you can just work out your figures which you want. Most of the models that I've done end up being about 4 lights in there, so I'll just stick the 4 in series, but it isn't realistic because every single room is illuminated at night time. So there you have one, and you can make loads up if you want. And then I've just stuck 4 together there and just daisy chained them all in series, and you can see that's what they look like illuminated, and they are quite bright. So you could add a resistance into that and bring it down a bit. In practice I've put 5 in series and they are very, very dim, which is great if you want a very dim light somewhere, and that's perfectly okay. Yeah. I've made up loads of these pieces of card in advance, and I stick them into a little box, and then I sit for a couple of hours, just make them all up, and it is quite simple. The card I use, if you're familiar with model card kits like Metcalfe or Super Quick, you end up with a lot of waste card. So don't waste it, cut it up into strips, and there you have it. Quite simple. The paper I use is just A4 paper. You can use your normal card glue that you use when you're constructing your kits, but if you are a scenery work you probably end up with a lot of PVA, and doing it with PVA is no problem at all. Just to show you in a kit, in the baseboard of the kit, all the cables come out, and one little tip is for you to twist your wires together before you bring them out to the bottom of the model, and then you know which ones are which. So when you go from the red to that one, to the blue to that one, and from the red of that one to the blue to that one, and so on and so forth, so you don't get them all mixed up. You can test them out if you mix them up, but it's always easier to do it like that. Just to help you, if you do have problems working out your resistance, this is an iPhone, and EE Toolkit is a decent little program, and in there you can work out your resistances there. I'll put in the voltage in is 12 volt, your VF, which is 3.2, and the current that goes through it is 20 milliamps, and the resistance there is 440 ohms, and I'll suggest you use a 470 ohm resistor, and that's yellow, violet, brown. So that tells you absolutely everything you need to know. It's a free program, but you can get the one with that you pay for, which unlocks loads of other things you can do with the program. So that's another little tip there. I'm not sure if it's on the Android as well. I haven't looked. And I hope you've enjoyed that little tip, and I'll see you again. So that's goodbye from Jeff Reedman. Thank you.